So if you look over here, okay, so this one I will need calculator also. You guys can also help me to calculate this, okay. So I think I discussed about this during the class, okay, but you can see also, yeah, calculate the mass of lead deposited at cathode. So if you're talking about lead, okay, this is lead 2 bromide, okay. So Pb2 plus, write the equation, plus 2 electron to give you Pb. Okay, this is important, first thing. And then from here, what I will notice, okay, I will notice that, okay, 2 electrons, so 2 Faraday is required to deposit 1 mole of Pb. 1 mole of Pb is 207 gram, okay. 1 mole of Pb, yeah, which is 207 gram. So now I know 1 Faraday, okay, is, okay, 96500 coulomb, okay. It will give you 207 gram, okay. If you calculate this, okay, this one you can calculate on your own also, no problem, okay. This one, if you times by 2, this is going to be 193,000 coulombs, okay, and then 207 gram, okay. Now, what is the amount of, okay, charge, okay, that is given, okay, in this setup, okay. So this is going to be Q equals to IT, okay. This is 1.5. The time must be in seconds, okay. So 20, okay, 20 you times with 60, change it, 20 minutes, okay. So if you do that, okay, so 1.5 times 20 times 60, okay, this one is 1,800, okay, coulombs, okay. So now, okay, instead of having this amount, I only have this amount. So I need to relate these two, okay. How do I relate? Okay, I can say that 1 coulomb is going to be 207 divided by 193,000. That is going to be the gram. So if I want 1,800, so I need to times, okay. So 1,800 coulombs, okay, is going to give me 207 divided by 193,000 times 1,800. Okay, your simple maths, yeah. So this one times, okay, times 1,800 times 207, okay, and then divide with 193,000. Okay, so this one you will get, okay, this is going to be 1.93 gram of lead. Okay, so that's why you get this. Okay, now I hope this is going to be clear. Okay, so this one, okay, is how you solve. Okay, how do you solve this? Okay, I will show you also. Okay, I will also show you the second example. Yeah, I think I will show you everything. Yeah, so we can go through this. So later when you try this investigation, you can do it very smoothly. Yeah. So you see here, calculate the volume of oxygen produced at room temperature and pressure. Okay. So when you have aqueous solution sulfuric acid, now this one, okay, I'm not here to discuss about electrolysis in IGCSE. Yeah. So we need to know, yeah, if you want to produce oxygen, okay, so oxygen. Okay, how do you get oxygen over here? Yeah, because it's concentrated aqueous solution, H2SO4, that's H plus, OH minus, SO4 2 minus. Okay, these are the ions that are going to be there. So I know that at cathode, you are going to get hydrogen gas, okay, when this one is discharged. Here, okay, OH minus will be selected. So how equation, if you want to memorize, is up to you, okay, but we will use this quite often. Okay, oxygen plus 2H2O, okay, plus, okay, this one, how many electron? This is going to be 4 electron. If you want to memorize, go ahead. Okay, because I think we are going to do this quite often. Every single time you want to derive, maybe it's not practical. Okay, but if you want to memorize, go ahead. So here, okay, it's going to be the same thing. What we need to look is going to be, this is 4 electrons. So it means now it's going to be 4 Faraday is required, okay, to produce 1 mole of O2. You write from the equation first, okay? And then, okay, 1 mole of O2 occupies 24 dm cube. Okay, so you write down 24 dm cube. 1 Faraday is, what is the charge? 96500. By this one, you should, by the time you finish this chapter, yeah, you will actually see this quite often, yeah? So 4 times 96500. Okay, that's going to be 386000 column, 24 dm cube. I want for 1 columns, okay, 24 divided by 386000 dm cube. Okay, 24 divided by answer. Okay, so I will get, okay, this one is going to be 6.218 times 10 negative 5 dm cube. This is going to be for 1 column. So let's actually find out, okay, how many columns that I have over here. So Q equals to IT. Okay, hold on for a minute. Q equals to IP. Okay, so here, okay, the current that I use is 0.5. Okay, then 30 minutes, I need to times by 60. Okay, I need to change it into seconds. So you calculate, okay, so 0.5, 0.5, okay, times 30 times 60, okay, 900, okay, 900 columns. So I am providing 900 columns. For 1 column is that much. So what I need to do, 900 column is going to be 6.218 times 10 negative 5. I need to times by 900. 1 column is this amount of dm cube. So now I'll be able to get what is that. Okay, so this one 900. Okay, I need to times with 6.218 mention negative 5. Okay, and I will get 0.056 dm cube. Okay, we want 3 significant figures, so you just put 560. Okay, so here, okay, even I think 0.056 is also okay. Yeah. So now I just want to check. Yeah, Catherine, can you understand this?
Yes, sir.
Catherine, is it okay?
Yes, sir.
Donna, is it okay?
Sir, how do you get the first equation?
How do I get the first equation? Yes, good question. This one is in IGCSE. Okay, when we do the electrolysis, right? We are going to use. We are going to have a selective discharge. Okay, so if you want to go and read more about this, you can go and read more about this. Okay, but how to get? I think the hint over here is oxygen. Yeah, but in IGCSE, they don't even tell. They just tell, okay, in this particular electrolysis cell, which one is going to be discharged. You need to select. And most of the time, okay, if you have sulfate and OH ions, yeah, most of the time, the sulfate is a very big ion, so they don't get discharged. Okay, so always OH minus will be discharged, and I want the OH minus to be discharged. Okay, if this one, it's going to be H plus, okay, plus electron to give you H2. So this one 2 and 2. So we come up with this equation for cathode. For anode, okay, how do we come up to that? Yeah, I can show you, yeah. But if you want to memorize that equation also can, okay, do remember OH minus, they are going to change into oxygen and water, okay, oxygen and water. So here, okay, what I can do is, you see OH, if oxygen is given off, H must be given off in form of water, okay, I put over there. And then I try to balance, okay, I try to balance over here. So if I put 2 over here for the oxygen, no, it doesn't make sense. 3 also doesn't make sense. So if I put 4 over there, okay, what will happen? I need to put 2 here, okay, 2 oxygen, and then it will become 4 hydrogen. It's balanced, okay, but the charges is not balanced. So it's going to be negative 4, okay, here 0. So I need to balance the charge by putting another negative 4. It means I put 4 electron. Yeah. So if you want to Memorize, go ahead. If you don't want to memorize also, no problem. You refer to the data booklet. Data booklet has this equation. Is that clear, Donna? But make sure you select the correct one. Yeah, the equation related to OH minus, there's many. Yeah, but select the one that gives you O2 and water. If you want to learn more, yeah, I will suggest, okay, everything is available online. Yeah, you get the ebook, yeah, for the textbook for the IGCSE. Go and read about electrolysis, because this electrolysis we will not cover in detail here. Okay, but it's good also to have a good concept of electrolysis. Yeah. Anyway, okay, but is it really necessary to know? Actually, no. Yeah, you can pick up as we learn. Yeah, and we can definitely pick up as we learn. I'll show you. Okay, another example. This is going to be silver at cathode. So if silver is going to be, you need to know how to write the equation. Ag plus is being discharged. So plus electron to give you Ag. Okay, you need to know this first. Once you get this, okay, you know that 1 Faraday is required to deposit 1 mole of Ag. And 1 mole of Ag is 108 grams. Okay, so 96500 column is going to be 108 grams of Ag. But I don't use this charge. Okay, I end up using Q equals to IT, which is going to be 1.8 times 45 times 60 in seconds. Yeah. So I need to calculate that 1.8, okay, times 45 times 60. So I get 4860 columns. So if I want 1 column, so it's going to be 108 divided by 96500. So if I want 4860 column, so it's going to be 108 divided by 96500 times 4860. Okay, so I just need to times this, okay, with 108 divide with 96500. So I will get, okay, 5.44 gram of silver. Quite simple. Yeah, I think once you get hang to it, okay, everything is going to be simple. But you see, there are 2 types of questions over here. One is something that is being deposited, or something that is lost, the mass is being lost. And another type of question is going to be related to volume. Okay, related to 1 mole is going to occupy 24 dm cube, okay, and so on. So it will be always repeating with these 2. Yeah, so you see, like this example, they say calculate the volume of hydrogen. So when you have that, so it's going to be H plus electron to give you hydrogen. So this one 2. So I have 2 Faraday is going to be for 1 mole of hydrogen, because we are talking about hydrogen gas. And 1 mole of hydrogen gas is 24 dm cube. Okay, and then 1 Faraday, so it's this one times 96500. Okay, column. Okay, so if I want 1 column is going to be 24 divided by this 2 times 96500. Okay, which is going to be 19300. Yeah. So if I want here, it's going to be Q equals to IT. Okay, it's going to be 1.4 times 15 times 60. You calculate that, you will get 1260 columns. So I need to just find out for this. So this value, I just need to times, okay, with 1260. Okay, once you do that, you will get, okay, this one, you will get this value. Okay, so you should be able to calculate quite easily.